capitalizing on automation to attain sustainable operations. So my name is James Haw. I'm the Vice President of Programs and Digital Strategy for PureCycle Technologies. Some of you may have heard Dustin Olson speak at this event last year. He's our CEO. I report directly to him. I've known Dustin for about 20 years, and he's the reason that I'm here at all. We worked together at a little refinery in Houston, Texas, and he called me from China around November 2020, and he said, I need some help with automation. And a mutual friend had said, well, call Jim Haw, he's big into automation, So he called me, and I said, let me write you a white paper. So we would text each other at night, and I would tell him what I thought he ought to do, and then he plied me away from Occidental Petroleum to come work for him. So that's why I'm here. So the first thing I need to do is do the obligatory PureCycle presentation to show you what we do as a company. Next slide. Oh, I have the clicker. Man, automation. Isn't this awesome? This is cool. So just the green button. You don't push the red button, right? That's got to be bad. Oh, it goes back. Okay, there I am. We'll go past. I'm VP of Program Management and Digital Strategy. Actually, I started out as Vice President of Digital Strategy, and I built the whole Born Digital program. Had a lot of fun doing it. Hired the IT department, hired the automation department, got that all assembled, and then our program manager, who's a good friend of mine, he got COVID in late 21, and he decided that, look, I've got to retire. He said, my family, they literally had an intervention. They didn't want me working anymore, so I really want to retire. And so Dustin started looking for a new program manager, and I'm kind of sitting over in the corner with my head down, because I've got an extensive background in program management as well. And finally, nobody else wanted to do it, so I'm doing it too. So that's why my title is that. So what PureCycle does is kind of why we're here, okay? We're all into plastic sustainability. So a lot of times when people hear plastics, they think, plastics are terrible. They see these seas of plastic in the ocean, and they see landfills full of plastic. And when we see that, we hate it as much as you do, okay? So a lot of people and a lot of these NGOs, they want to get rid of plastics. Anybody here think you can get rid of plastics? Anybody at all? You can't. Okay, so I'll give you a good example for the moral case for plastics, and then I'll move on. But 40% of infant mortality occurs in North Africa. 40% of the planet's infant mortality. And there's been a mission afoot for the last 10 years to push incubators over and help them get over this infant mortality hump. 90% of an incubator is made out of polypropylene and other plastics, okay? So either you're for life or you're not for life. I know that seems pretty hyperbolic, but it wouldn't be possible to help them solve this problem if it weren't for plastics. Another good example is, I say this and people think you're being facetious. Plastics actually save the planet. 40% of your car is made out of plastic, right? I got in a Tesla, the first time to ever drive a Tesla today. Actually, it took me 5 minutes to figure out how to turn it on. Weird. And it was almost all plastic. But the plastic in the car only weighs 10% of what all the other materials would weigh. So your gas mileage automatically goes up, right? So you're using less gas, less emissions, right? So it's actually saving the planet, right? So that's what we're about. We take post-consumer waste polypropylene and we purify it. We just wash it. We scrub it at the molecular level. That's all we do. We don't break the molecule down. We don't reconstitute it as plastics. It's plastic from the beginning to the end. We just clean it. I mean, it literally is that simple. And the process is actually pretty simple, although I can't share it with you. So go to the, okay. All right. So our mission, transform plastic waste into an infinitely sustainable material. As far as we know, we can infinitely wash that molecule. So we're not cracking it. We're not changing it. We're not adding anything to it. We're just washing it, right? So it comes back to us as waste. We wash it again and put it out as virgin-like plastic, crystal clear virgin-like plastic. We want to end the culture of single-use plastic and create a truly circular economy. So it would be great, although we know we can't do it, ultimately, the math just doesn't work out, but it'd be great if we never had to use oil to make plastic again, right? We just keep recycling what we're using and putting it back in the front of the line, although there's always going to be some waste, right? And our actions have transformed polypropylene plastic into a versatile, replenishable resource through the unprecedented purification process. So we do that. Right now, if you use plastic polypropylene, you throw it away. I mean, anybody here take a takeout from a restaurant? What do you get it in? What do you get it in? It's a little black plastic thing with a lid on it, right? That's all polypropylene. Anybody go to a game, a concert, or a game at a big venue, maybe a ballpark? Anybody? Nobody? Okay. Play along. All right. So you go to one of those venues and you get the souvenir cup, right? You go to Houston, you get the Minute Maid Park cup. I've got like 1,000 of them because I'm cheap. I don't want to buy glassware. I just take that home with me. That's all polypropylene. Okay. If you use a mechanical process to recycle that polypropylene, all you can make with it is like a park bench, or you can make a trash can out of it, or you can mix it with sawdust and you can make a deck board, right? You can't use the plastic in all its original use cases. So that's what we do. We purify it, we take it back to all its original use cases, and you can use it in food grade. You can use it in, Procter & Gamble, they're using it in all their processes, all their products rather, right? L'Oreal, they're using it in their product containers, that sort of thing. Because here's how we do it. We process feedstock, we bring it in, we grind it, we wash it, we get rid of the organics. We take it through an extraction to extract the waste out of it. We do a filtration, we get rid of the byproduct. It's a byproduct. We don't take anything to the landfill. We have this great company right now that's coming to us, taking our byproducts, which is any other type of plastic and other waste that we pull out, and they're making house-sized Legos out of it. It's about the size of a cinder block, but it's a Lego, and they can build a house in like 2 days. Pretty cool. And then we do product processing. We might add additive to it. We might add color to it if that's what our customers want, but that's not our primary mission. Right? Our primary mission is just to make the plastic clear again. There are no chemical reactions. We do it at a very low carbon footprint. So we talk about automation. I recently, we talked about automation and sustainability and what automation can do for sustainability. Sustainability, anybody ever seen ChatGPT? That's like the cool thing today. Almost like half the audience here, right? Okay. So I go to ChatGPT just for grins, and I ask, what is sustainability all about, right? So sustainability is about meeting the needs of the present without compromising the ability of future generations to meet their own needs. It involves balancing environmental, social, and economic concerns to create a more equitable and resilient world. About right, isn't it? So I had written in my presentation that sustainability is about using resources in a way where they never run out. So wind, hopefully the wind's never going to run out, right? I guess if the earth starts rotating, maybe we'd have bigger problems if that happened. So that's what PureCycle does, right? So in order to be able to stand on this stage and say we're all about sustainability, we have to be about sustainability and everything else we do to do what we do, meaning we have to watch what we use for energy. We have to create processes that make our plastics more efficiently, where we use less energy. We have to monitor the energy usage and monitor the equipment that we use to distribute that electricity, so that we don't incur shutdowns or unplanned outages. because every one of you in the room know that if you shut down and it's an unplanned outage, first of all, it's going to cost you 8 to 10 times what it would cost you if you had planned an outage, and you're going to use way more energy, and you're going to have more emissions for that outage, right? So it's all about reliability, making sure your plant runs the way it should run, and planning all that in the beginning. So we set out to do that. We said, look, how can we make it the most reliable and data-driven plant? So we built a born digital program. And our mantra was no transformation, no digital transformation, which is the fourth industrial revolution. You all know about that. We've been buzzword for the last few years. We don't want to go through a transformation. So Mark mentioned putting people out of work earlier. He said, back when people think about automation, think about, well, you're just going to put somebody out of work, right? So back when the automobile, which is, the thing that touches everybody the most from automation, back when the automobile came out, everybody was afraid the horse and buggy industry was just going to die, right? There are more horses and buggies now on the road than there were when the automobile came out. Of course, a lot more population, but still, it's still a thing, right? So automation doesn't kill things, it just allows you to live healthier, at less cost, and make your life better. So here's what we did. So you'll notice, I don't know if you can see those words very good, but this is the PureCycle blue. So we planned everything. We built it like a planned community. We took time to build the architecture. We took time to think about all the things we might use, all the different components, digital twins, process and physical twins. We talked about using, everything related to safety. You look at the kind of the wheel we got around the data lake. Process automation is at the top because that's what we're doing, but everything related to those other fields take data, and the automation system takes data from it. We created a data lake and a data fabric. That's what the dark blue lines are meant to represent. So you have engineering that occurs. You want to make sure engineering follows the Born Digital program, right? You want to make sure that they understand how it's supposed to be put together. And when you make changes, you have to make changes very carefully. You have to think about, how am I going to conform this change to what we're trying to do as a company? HSE, some things we did, we have awareness out in the plant. If you walk out in our plant, we know you're there. We have a 3D digital model on a big screen in the control room, and there's a Google bubble on it that says Mark Gupta, and it knows Mark's in the plant. And the cool thing is, if Mark were to walk in from the street, our cameras see Mark, and they know it's Mark because they recognize his face. And it says Mark Gupta's in the plant. And it says Mark Gupta drove into the plant with a different car that he drove in last week, because this license plate's different than the one he had last week. And if Mark stops moving for 4 minutes, we send somebody to rescue him, right? And that's all through automation. It's all through the camera network. It's all through the triangulation of his fob. He'll have a fob if he goes out in the plant. And if he stops moving, he might have a heart attack. He might get hurt. He might get harmed. If he stops moving for 4 minutes, we go find him and we grab him, right? If he activates a safety shower, we know which safety shower it is. We know where it is, and we send people to help him. We don't make him wobble back to the control room and say, hey, I got acid in my eyes. We don't have any acid in our process. That'd be really unique. But so, the data comes from everywhere. Process automation, maintenance, engineering, operations, HSE, and the business network, right? Because as my predecessor talked about earlier, you want to use like robotic process automation and other things so that you don't remove people from their jobs. You just make them do or allow them to do higher order value added tasks, right? Rather than shuffle papers, let a robot do that, right? That's in the business side. So we build it, again, like a planned community, more or less a planned digital community, and we do all of this. So when you look at each one of those categories, these are the things that we set out to do. And it's almost unrecognizable. I can't even see it from here, but I know what's in each box. So we have digital twins, both process and physical. So let's just talk about the physical. I'm not going to talk about everything on here because it'll take too long, but talk about the physical twin. It allows you to do engineering in a way that you had not necessarily done it in the past. Everybody started out with ISOs. They build an ISO, they go out and they build a piping, and they know where the valves are, and they're precise measurements, right? With the 3D model, if you want to add something to that model, you know instantly whether or not it's going to fit, right? You just have to understand what you're doing, what you're putting in. The way we implemented our model is you can wear a headset while you're walking out in the plant, and you can touch a pipe virtually, and it'll tell you what direction the flow's going. It'll tell you what temperature the pipe is, the process in the pipe is. It'll tell you what the flow is in the pipe. Any data that's available in the Delta V system, it will tell you that right there. If you really want, you can push a button and it'll pull up virtually, while you're in the field, it'll pull up a copy of the PNID. So you can look at the PNID while you're in the field, and it's an incredible training tool, right? So it's not something that just engineers use, it's something operations will use, right? Okay. And of course, again, my predecessor talked about digital twinning for the process, and that's amazing. There's lots of things you can do about that. Our process doesn't work real well in first order models, okay? It's a hypercritical phase. So it does weird things from a physics and chemical standpoint, but that's why you have this system in place so we can learn as you go along. It takes about a year to learn and understand how the process works, and then you've got your full-fledged digital twin. So the CMMS system, we talk about the CMMS, is something that's been around for what, 40 years, 30 years? The CMMS, if it's really sophisticated, you know exactly how many parts you have in the plant for everything, right? If you're wearing our headsets, you go out in the plant and you virtually touch a motor, it'll tell you every part we have on site. It'll tell you the make, model of every part that's replaceable without having to remove the equipment and send it off for repair. It'll tell you everything you need to have to work on it, right? So it makes it easier. I don't have maintenance techs going and, researching things and going into Google and calling Emerson saying, what part do I use? It knows which part you use, right? So tons of stuff on there, and I'll be happy to answer any question. So just some pictures to kind of trying to drive it home. So our central control room, we can see it anywhere in the world. We have a hub right here in Orlando, down by the airport. Our main office is out there on Hazeltine National Drive, and we have a control room there. Now, we're just building our first plant. We're almost finished. We're about 75, 76% commissioned to date. Hopefully by the end of March this year, it'll be running full-fledged or full tilt. We'll be able to see everything that our control room can see from that location here in Orlando. Now, in the beginning, we're not going to do any control. We're just going to use it as a launching point for maturity of the process twin, and to be able to make changes and debottlenecking and efficiency improvements, et cetera, et cetera. So, but it's still amazing because you can see everything from there. We're also using it as an EOC. We'll be able to see all our cameras from that location, and our CEO that lives here in Orlando, he can be there in the facility virtually if anything were to ever happen. We're using mobility. I mentioned the RealWear lens. We're using mobility for maintenance, operations, HSE, different things. If someone, like one of our process engineers, for instance, goes out in the field, he or she's wearing a RealWear lens, they can call Emerson and saying, this thing's making a funny noise. It's blinking a light I've never seen before. And the gal will say, okay, I'm seeing what you're seeing, here's what you're doing, right? I don't have to have that Emerson person fly from Houston or from Indianapolis or wherever they're going to come from to come to the plant to tell me how to fix it. They can tell me right then in real time what to do. I mentioned the digital twin. This thing is tied into our maintenance system, our engineering system, our operations system, so that you can really use it as one single version of the truth. And that's really what gets you. You know, that's what creates confusion in your business is if you have more than one version of the truth, right? You have to have everybody working from the same vocabulary, the same encyclopedia, the same Wikipedia, whatever it is, to be able to make those decisions you need to make. And then, of course, maintenance process is fully digitized. Our maintenance techs will go out with tablets. Their work orders will be on the tablets. Their work orders are in the digital twin, so if the operator wants to know what work is going on, he can hit a button and it will erase everything on the screen, but the location of maintenance that's going on, it'll tell him what the work orders are. It'll tell him who's working on it, who's in the field, because he can see their Google bubbles, and he can tell when it's going to be finished, right? The maintenance tech can write work orders straight to our maintenance system from the tablet as they're walking around the plant. It's fully digitized, right? The cool thing is when the maintenance tech shows up in the morning and they need a permit, let's say to remove a valve, the operator looks at that digital twin and says, okay, I want to remove that valve. And he hits what's called a cog. It's a cognitive visualization. He hits that button, tells the operator everything they need to lock out, already built in. So it's not about going to a file. Let me pull up, and we locked that thing out about 10 years ago. Let me pull that up and see what I have to, lock out. Or it eliminates the possibility of missing something that would put someone in harm's way, right? So. And again, HSE systems fully digitized. All of our LOPAs are done in Excellentia. All of our PHAs are done in Excellentia. We have another program that manages permits and our incident system, both safety, environmental, and otherwise, right? So it's all digitized. You can get that data like that from anywhere in the world. So that's the short presentation, because I usually do this presentation and I go into detail and it takes me like 2.5 hours, but Gupta wouldn't let me have that much time, so sorry.